Good morning to everyone. Myself Dr.UdhayaKumar, Assistant Professor, Department of ECE, Hindustan College of Engineering and Technology. My presentation topic is Bipolar CMOS technology, simply called as Bi-CMOS. And my contents are what is bipolar, then the classification of the bipolar technology, then you have to see the characteristics of bipolar, then the next one is the what is CMOS, then the classification among the CMOS technology, then the characteristics of CMOS technology, then the next one is the what is Bi-CMOS, the combination of bipolar and CMOS, then the bipolar CMOS fabrication, then the merits and demerits for the bipolar CMOS technology, then finally we go to the applications of the bipolar CMOS. First see that what is bipolar technology. So bipolar transistors, that's the earlier devices, that is the first development, are the part of ICs, and their operations is based on the two types of semiconductor materials, that is named as N-type, that is excess of electrons, and P-type is the excess of holes. And it is named as bipolar because its operations involves the conduction of two carriers, one is electrons and another one is holes. And BJT also is called as a current control device. The classification of the bipolar technology is bipolar is classified in two categories. The one is the NPN and another one is the PNP transistor. First see the NPN transistor. The emitter is more negative with base and also with respect to the collector materials, and based on this NPN transistors is more negative with base and also with respect to the collector material, and base is lightly doped with the holes, depends upon the construction. And this is the construction, and this is symbol for the NPN transistor. Then the PNP transistor, the emitter is more positive, that is just opposite for the NPN with respect to the base and also with respect to the collector materials, and this is a symbol and this is a construction for the PNP transistors. Then the characteristics of bipolar CMOS, the characteristics of bipolar technology, it is having that higher switching speed and higher current drive per unit area, then higher gain, then the better noise performance compared with the CMOS, and better high frequency characteristics, then improved I/O speed and power dissipation, then lower input impedance and low packing density, then higher transconductance material, then it is unidirectional one. Then the next one is the CMOS. CMOS is named abbreviated as the complementary metal oxide semiconductor. It is a major class of the integrated circuits. Nowadays they are using that CMOS. All the ICs are fabricated by using the CMOS technologies, and CMOS technologies is majorly used in the microprocessor, controllers, then static RAM and other all the digital logic circuits. Then the CMOS technology is also used as a variety of analog circuits also, not only in the digital analog circuits such as image sensors, data converters, highly integrated transceivers for the many types of communication purposes. Then in the CMOS technology circuits, both N and P type transistors are used to realize the logic functions. Then the classification of the CMOS technology. CMOS is classified as first NMOS, the second one is the PMOS. According to the construction, see the NMOS technology. So NMOS is built on a P-type substrate. So substrate is the base, it's a raw material, and over the N-type source and drain materials are diffusion on the P-type substrate. So we are going to fabricate an NMOS transistor, means we are going to take an opposite material, that is a P-type substrate, that is N opposite is a P. So we can take the P as the raw material, and you have to over that we are going to source and drain diffusions. The diffusion should be carried out over the P-type substrates. The NMOS majority carriers are the electrons, therefore that much faster than the PMOS material, and this is symbol for the NMOS transistor. Then the PMOS, just you have to opposite for the NMOS transistor, the same construction, that is P channel MOSFET transistors in the P type, source and drain are diffusion in the N type substrate. So PMOS, that is PMOS having that N substrate, and over the source and drain of the PMOS transistors are diffusion on the N-type substrate. Here the majority carriers are the holes. PMOS will conduct when a low voltage is applied, and is just opposite for the NMOS. In the MMOS, having that higher voltage, you are going to carry it out for the operation. Then the characteristics of CMOS technology. It is having that lower static power dissipation that compared with the bipolar. Then higher noise margins, then higher packing density, then higher input impedance, then higher delay load sensitivity, and low output drive current, and bidirectional capability. Just opposite for the bipolar technology. There is unidirectional one, here it is bidirectional. Then the next one is the Bi-CMOS. They are a combination of the CMOS and bipolar transistors. It combines the bipolar and CMOS transistors in a single integrated circuit. And what is the need? Why we are going to combine the bipolar and CMOS? We are going to utilize that both the features that is adopted in the bipolar technology and CMOS technology, and it is especially used in the speed. We need for that highest speed means we are going to use the Bi-CMOS. In the 1990, two separate technologies were incorporated, that is named as bipolar transistor and CMOS transistors in a single modern integrated circuits. Bi-CMOS is able to achieve VLSI circuit with a speed, power, density, performance previously unattainable with the either technologies. That is the major feature for it. And this is the bipolar CMOS fabrications. It is the combination of the both CMOS and bipolar. So that is having that this is the N-well region, and this is the P-base region. For that, that is the emitter, collector, and base materials are incorporated, diffused in this side. So this is the top view for that. This is a cross-section view for the fabrications. Both CMOS and bipolar technologies incorporated here. This is the BCCD. There is a buried N plus substrate sub-collector region for that. And this is the P-base region. And this is a base contact. This slanting line that is for the use for the base contact area for it. And merits for the bipolar CMOS technology: improved speed over CMOS, improved current drive over the CMOS technology, improved packing density, on all the features, and that compared with the bipolar and CMOS. Both the things are here that incorporate, that is higher input impedance, low output impedance, higher gain, and low noise. And drawbacks: limited drawbacks for the increase in manufacturing process, that is the complexity is increased, higher cost, and speed degradation due to the scaling. We need for that, we are going to increase the scaling means we are going to the speed is approximately degraded. The performance is also the degraded when increasing the scaling of the transistors. Then longer fabrication cycle time needed for to fabricate the that IC. Then the applications of the bipolar CMOS. This technology is used to as an alternate of the previous bipolar and CMOS technology. In some applications, the Bi-CMOS speed performance is better than the bipolar, because it is very especially used for the speed. This technology is well suited for the intensive input output applications, and the applications of the Bi-CMOS were initially in the RISC microprocessors rather than the CISC microprocessors. Thank you.